Awesome. So given this was our month of how to get started with Python, learning Python, teaching people Python, I figured it'd be an awesome opportunity for us to talk about how to get people to start off with Python on the right foot. So I know it says half a dozen ways to fail at Python. If you're not familiar with Python or you're new to programming in general, there can certainly be some landmines that you may step on along the way. I'm hoping I can try and uncover those things. So if you didn't know already, my name is Calvin Hendryx-Parker. I'm CTO and co-founder of 6 Feet Up. We're a Python and cloud consulting company out of Fishers, Indiana, and we do lots of work in Python. I myself have been using Python since the year 2000, so that puts me probably in the older category of Python user folks. So putting this talk together was quite interesting because when I kind of thought back through what it was like to learn Python, it was so slow and gradual because I'd done it over so many years that I'd kind of forgotten what it was like even to try and just get started. It just seemed so natural to me. So I take it certainly for granted that Python is easy to get going. But as I dug deeper into it, I found that that's not necessarily the case. There are certain places, certain dark areas I don't want you guys to end up in. I don't know if you guys are fans of the comic XKCD. If you have seen this comic, basically in April 2018, Randall Munroe posted this comic about his own computer. Basically, he's a Python user, and along the way, he has probably installed numerous versions of Python, some from the python.org download, some from Homebrew, some with like the built-in OS Python, some from Anaconda, some from random places, some things he just compiled on himself. This isn't to say that Python is bad. I think he did bad things to his computer. And I want to make sure you guys don't go down that road of doing bad things to your computer. If you kind of read the little bottom text there, it says, "My Python environment has become so degraded that my laptop has been declared a Superfund site," especially by the Python Environmental Protection Agency. So if we can keep you from going down this route, I will try to do that. That's my goal for today with this talk. And we're going to talk about 6 common failures, at least things I saw right away when I was trying to get kind of rewind, go from 0 and move forward, what I thought were some of the big landmines that most people might run into. And so we'll get you guys into a good spot. I think one of the powers of Python is it's very flexible and easy to use, and there's many ways to get started. But sometimes you have to be a little opinionated, especially if you're going to be using Python in a professional setting. If you're just kind of hacking on a couple of scripts here and there, there'll be some certain things you can do that are probably okay. But if you're going to be a genuine, real Python developer, there's definitely certain practices you're going to want to follow to make sure that you don't basically mess up the computer, which is the thing that makes you the money, your environment into a Python Superfund site. So let's move on and hopefully avoid that. One of the first things you may run into is maybe you don't even have Python yet on your system. So if you've ever run the Python command and seen command not found, gotten a nice punch in the face because you thought you'd be ready to go, let's talk about fail number 1. We want to be able to install Python, and we want to be able to do it in a sane way across different operating systems. One of the things you need to be careful of is that, for example, Python comes pre-installed on some, I see a lot of laptops in the room already, where Python is certainly on that computer, like on your Mac, on my Linux system, on that Mac. Python is installed by default, and it may be an old Python. So for example, on OS 10, the Python is version 2.7. Something ancient, which is also linked against a very ancient version of OpenSSL. What's wrong there? Why would that be bad? Well, first of all, you're going to be using legacy Python. Who knows when Python 2 stops receiving all support? January 1st, 2020. We don't have the stickers. We've got, so come to IndyPy Mixer, and I will guarantee you every one of you can have a nice little tombstone sticker that commemorates the death of legacy Python. Python 2.7 will cease to receive updates after January 1st, 2020. And so Mac OS 10 has basically got its own Python, and what you should consider that Python to be is its own private Python. You shouldn't technically be using that Python. It's for its own internal purposes. And a lot of other operating systems take this same stance. And they may not have old Pythons, but they're definitely using Python for their own internal purposes. For example, I'm running Ubuntu here. Luckily, Disco Dingo, whatever the latest 2019 version of Ubuntu is, ships with Python 3.7.3 out of the box. This is phenomenal, folks. That is the latest version of Python you can get. The problem is it's missing things. And it's missing things because they put it on there for their own specific use cases. And so I'll talk about what it's missing here in a bit. And again, Red Hat's like that too. They use it internally for their own purposes, their own processes. So you should consider the OS installed Python to be owned by the operating system, and you should not touch it. For if you do, you risk destroying this computer and turning it into basically a dumpster fire. Let's try and avoid that. So if Python's present and you're serious about your craft, you will install your own private Python in some manner other than using the one that's there from the system. So let's talk about installing Python. The first case I'd like to talk about is just Macintosh. If you're on a Mac, it's very easy to install and use Homebrew. These slides are actually up on GitHub already. So you can actually go to github.com/CalvinHP. You'll see that my most recent repository is this whole presentation. These blue links are actually links in the text, so you can actually go to the page to learn how to install Homebrew. But if you're a developer, you're going to have Homebrew installed, and you're going to just brew install Python. They are up to date. They are giving you the latest version of Python, and they're giving you all the tools compiled in and ready to go for basically a Python developer ready to go and build Python apps with. This gets a little trickier when you get into Windows, although soon this won't necessarily be the case. There is a package manager on Windows called Chocolatey. Any Windows users in the room? A couple. So you can install Chocolatey and do basically from the command line, very similar to the Homebrew environment where you can say Choco install Python. That will also get you Python 3.7. Although I'm happy to report in the Microsoft Store, you can also just click Go and install Python 3.7. And if you're, that thing not working. Oh, there we go. It is E for everyone. So we are very safe in installing Python to the system. It will not corrupt your children. It is E for everyone. Oh, and don't hesitate to ask me questions along the way. There may be things you're like, what if I did X, Y, and Z? Is it going to destroy my computer? I'm happy to answer that anytime we get to a slide where you want to ask that kind of question. And then on Linux, as I mentioned on my system, I have Linux Ubuntu running Python 3.7. The previous version was running, older version Python 2 was the default for like the previous LTS version of Ubuntu. You're going to want to still use a newer version of Python, and I will talk about how you can actually get a newer version of Python, or specifically even an older version of Python if you're working on projects that have different dependencies on different versions of Python. Because not every piece of software is going to run necessarily the same version of the interpreter, because they may have different development life cycles, and they may be at different places in their projects. Now, the issue I ran into is I upgraded my machine recently from whatever the 2018-10 was to 19.4, while the Python Linux, or the Python provided by Ubuntu is now the default to Python 3, it did not remove my Python 2. It also did not change when I typed the word Python, I was still getting a Python 2.7 interpreter. So if you run into that same kind of problem, you're going to want to be able to prioritize the Python 3 interpreter over the Python 2 interpreter, and this is actually how you do it. And so these are all on the GitHub, so it's easy for you to find. But basically in Ubuntu, you can specify, when I type the word Python at the command line, I want to get Python 3.7 preferred over 2.7, even though I have both of them installed at the same time. And you can actually switch this by using the update alternatives config command to change it on the fly if you actually ever wanted to switch back and forth. But this is mostly so that kind of convenience that when you type the word Python, you get Python 3. I'll show you later kind of a more supported or more sustainable way of being able to use older versions of Python simultaneously with new versions of Python in your projects. So once you think you've got it installed, let's verify we've got it installed, and let's also verify we've got the latest version installed. So running the Python command --verify, that actually gives us the string saying what version of Python we have. So this is modern Python, and we're very happy. Now, for me personally, I'm about to run into some issues. I'm about to run into like basically fail number 2, which is import error, no module name requests. So say you've heard about this awesome library online, and you want to actually install and use this library inside your own projects. How do you get third-party modules and tools into your Python interpreter so that they're usable for your projects? So we're going to talk about a couple different ways of doing that. This first fail is basically what I want to talk about. Probably one of the most important things I talk about here is if at all possible, we can avoid using Sudo or administrator mode on your system, you're going to be very much better for it. If you don't use sudo, you don't risk technically overwriting files and modules in Python that is in the base install of your system. And there are definitely ways to install and be productive with Python without actually ever using the word sudo in the command line. Now, there are certain cases where you may need it, but it's very rare. So I would say this would be a kind of a last resort where you'd reach for that. And I'm going to show you alternatives to be able to use non-sudo techniques for getting Python packages installed using pip. Now, the first thing I tried to do was actually pip install HTTPy, which is uses requests. So it's kind of a similar tool, actually leverages the requests tool underneath, but it makes a nice little command line utility. So if I, as a user on my system, typed in pip or pip3 install HTTPy, if I'm not doing this with sudo, it's going to try and write into my system Python's site packages. So when you install Python, it has the Python core language, it has the Python standard library. Everybody familiar with the standard library? So nice batteries included. Well, in addition to the standard library, you typically are going to install other third-party packages to make your life easier, to help you build projects. And you'll use this pip command to be able to do that. Now, the pip command by default is going to try and write into areas like user, local, lib, Python 3.7, disk packages, or site packages, HTTPy. But since I am not root and I'm as my own user, it's going to say, sorry, permission denied to do that. This should be your first warning. You probably shouldn't be doing this because you don't want to pollute these package spaces that are part of the system. Now, the issue you may run into, you may not know it right away, is you may install a conflicting version of a dependency because your package you're trying to install has a dependency newer than what's on the system already. And maybe some operating system level tool or utility is actually using that under the covers, and you've just broken their tool. And now something is not happening on your system that's supposed to be happening, and you may not find out for a month because the maintenance hasn't happened the way it's supposed to happen. So be very, very careful to not install those things, and actually to consider using this use -- user option, which I'll talk about here in a moment. Oh, actually, so if you do use this -- user option, which I'll show it when we talk about pipenv, that uses the user scheme where I can install these Python packages what appear to be in the system Python, but they're installed into my local home directory. So I've not overwritten files into the system Python. I've actually been putting them in my own home directory. It's still not a wonderful option because it will still interact and possibly conflict with packages that are installed by default. So if you do try to upgrade a package that's already existing in the system Python, it's going to fail and not let you do that at all. So I say no sudo except for possibly here. We will talk about in the next fail being able to use virtual envs and sandboxes. Well, to use a sandbox, you somehow have to be able to install that sandbox, and the tool you're going to use to install the sandbox is actually written in Python. So how do you get the Python tool into your system so you can actually make little sandboxes? Kind of a catch-22 type situation. You could, and I've done this before fairly safely, sudo pip install virtual env, and be able to then use this virtual env tool during our next phase of the talk. There are ways around this. This is probably one where we probably should specify -- user so it installs into our home directory and doesn't write files into the system area at all, and then you wouldn't actually need to use sudo. So there are ways of avoiding using sudo, even in this case where you want to install a global, well, it feels like a global tool. You can install it at your own user level and not affect the rest of the users on the system or the global Python at all. But we'll come back to this topic a little more as we talk about virtual environments. So fail number 3, my 2 projects need different versions of dependencies. This is not uncommon in the web world, where you may be working on a long-term support project that's not doing active development but is under maintenance, and maybe, for example, it's using Django 1.8, which is a long-term support version of Django. And you've got other projects where you're using latest and greatest. And you want to be using Django 2.2 and use all the bells and whistles. But you can't have those 2 packages installed simultaneously because they share the exact same name. So if you were to pip install Django equal 1.8 and then try and pip install Django equal 2.2, the 2.2 one is just going to overwrite your 1.8 one, and then your 1.8 project is going to cease to work. So with this case, this is a place where we want to be able to use these sandboxes, basically little environments, mini virtual, we'll call them virtual environments for this case, because that's what the name of the tool is. But we'll create specific base sandbox for our projects. This tool was actually created by Ian Bicking, as it's called virtual env, And as of Python 3.3 or newer, it's actually included in the Python interpreter. And I learned this literally putting this talk together. I've still been using the virtualenv script for kind of legacy Python to make these virtual environments, which works, but can be troublesome, and I'll talk about that. But in our case, we can actually make a new project, cd in that project directory, run the Python command with a -m flag. In this case, -m says, run some module in my Python path. And Python includes in the standard library a venv module. And then the next argument is what I'm going to call my virtual environment. So you see it's like venv space venv. That just says I'm going to use a virtualenv module to create a virtual environment called venv. So don't be confused by that. We're just using a convention here. A lot of virtual environments will be named similar to that. They may be .env or .venv or venv or env. And the reason for that is many of the source control tools are already set up to ignore that directory. So if you have it inside your project, you don't typically want to check these files into your source control. So using a name like venv, most tools are going to typically ignore that directory just by default. So you don't have to worry about accidentally checking in a bunch of like compiled code or the libraries that make up part of your project, because that's all handled in another area of your project. Now let me show you, so unlucky me, I went to go do this on my Ubuntu laptop yesterday and ran into this problem. And this is what I was talking about earlier, that the system Python for Ubuntu is missing bits. They kind of packaged up a lean version of Python for their own use case, and they happen to include some extra packages that can turn it into a full-fledged Python if you like. So that's why when I went to go run this, it said, sorry, you don't have this tool called ensure pip, and that'll come if you install this extra dependency package onto your system. Which, if you do that, it will then work, but there are ways around this without having to use the sudo command to install other packages into your system that aren't necessarily needed, because maybe you aren't really using it for anything else other than just your own personal development. So I want to show a quick little demo. Here we go. So I've got I'm in my documents directory. I've got a project 1 and a project 2 directory up here. So if I go into project 1, and if I do an ls, you'll see there is a directory there called venv. Now, with virtual environments, if I'm using my Python right here, if I just type Python, I'll get a Python 373 prompt. And if I type which Python, it'll show me that I'm using one out of pyenv, which is actually determining, it's another tool we'll talk about as we get into some further landmines. But I want to be able to use the libraries that are installed into this specific version of Python. So if I do this, and I try and import Django, it's going to say, sorry, I don't have a module named Django in here. But if I activate my virtual environment, so to activate a virtual environment, then activate. Our virtual environment is now activated. So this is common with if you're using virtualenv and pip, this is actually how you will activate your virtual environment, is to just source that activate script right there. And then you'll see that you'll know your virtual environment is active because it'll put on your prompt in some manner, in parentheses, the name of the virtual environment that is active. I already know what you're going to ask me. If all my virtual environments are named venv, how do I know which one's actually active? That is definitely a problem if you're using this convention. And there are lots of people who have hacked their fancy prompts, which you can see I've got a nice fancy prompt here doing all this crazy stuff, to change that to show what project you're in addition to a virtual environment being active. That does not out of the box. The out-of-the-box experience is going to be what's the name of your virtual environment. But if you don't continue using virtual environments like I'm showing here, and we'll use them with Pippins later that I'll show you, it will rename them or name them automatically for you so you can actually tell them apart. But you will definitely have to be careful if you're using that convention of naming them venv, that you don't have one virtual environment active and think that another one's supposed to be active. So now if I type pip freeze, you'll see here I've actually got Django 1.8 installed inside this environment. There we go, 1.8. Now, if I deactivate this environment, and I go into project 2, and I'll run the same command to activate project 2's environment, because they're both named venv, and type pip freeze, we'll see here we've got Django 2.2. So one project's using 2.2 and one project's using 1.8. And neither of them are installed into the global Python, which is nice because I don't have to worry about some kind of artifact being picked up from the global Python namespace as I'm using it in my other projects. I really want to keep my system as clean as possible so that these little virtual environments will typically match, one for one exactly what will be deployed into production or the staging instances, so I can catch strange edge cases before they actually get into production. I mean, you could very easily have the case where you're depending on some dependency that's already on your system but doesn't exist on production, and you have forgotten to put it into your requirements file and tracked it appropriately, and now when you go to deploy, it's all broken. So speaking of that, with virtual environments and using pip, you need a way to track what versions of those things are installed. And if you see in my current project directory, I just have that virtual environment, but if I wanted to hand this off to somebody else so they could start working on it, I need to tell them what they need to get installed so their environment matches mine. So typically what you do is you do pip freeze, and you would just pipe that to a requirements.txt file. And now if we cat that requirements text file, it contains that output, and now when someone else goes on their machine, they just type pip install -r requirements.txt, and now they've got hopefully the exact same environment as we do. That's not guaranteed, but it's pretty close. I mean, it's the best thing we've had for quite some time until the next tools I'll start talking about. So that's how we can actually use virtual environments. Let me get Chrome back up. There we go. So that's with Python 3.3. If you are using a version of Python older than 3.3, or you happen to have to be working on legacy Python projects, you can still use the virtualenv tool, but you will have to install it. So that's where you would sudo pip install or pip install -- user virtualenv, and actually now you have the virtualenv command available to you to use. What's the possibility, what could be wrong if you're using this virtualenv tool, like in this case right here, where I'm doing virtualenv space venv? The issue is going to be you don't know exactly what version of Python is going to be installed into that sandbox. You have control over it, but you have to be very explicit. So with this technique of using virtual sandboxes and kind of prior to Python 3.3, you have to be explicit, or you should specify what version of Python you want to use. For example, you could install virtualenv into your Python 3.7 global interpreter and make Python 2.7 virtual environments. You just pass in what interpreter you want to the command, and it'll make a new sandbox with that specific version of the interpreter. So that's the thing to be aware of. When you're using the previous technique, where you just do Python -m venv, it is going to make a sandbox with that version of Python you called it from. So if you want to use a different version of Python, you would say Python 3.6 -m venv, and it makes a Python 3.6 sandbox instead of a Python 3.7 sandbox like you would get there. And now for a little bonus material. If you've all been virtualenv fans for years but never discovered virtualenv wrapper, I highly recommend this tool as well. I use this mostly for tools on my system. In this case, I'll make a virtualenv called tools, and what it does is it actually hides it in the background. It makes a .virtualenv directory in your home directory. We'll build up multiple virtual environments in there so you can activate them and switch between them quickly, and it won't leave those VM directories kind of littered about inside your project space. Let me show you what that looks like. All right. So I'm going to deactivate this environment. And so for example, for the make virtualenv, we'll call it IndyPy. So this is actually making a virtual environment inside of .virtualenv called IndyPy. It will go ahead and activate it for me. And when I type pip install requests like that, oops, I had to say install. It now installs requests only into my virtual environment of that specific version. So if I do pip freeze, you'll see I have request 2.22. If I deactivate and do pip freeze, and I'll grep for requests because I know it's here, you'll see I've got 2.21. So the system Python's got request 2.21. I now have 2.22 in my own virtual environment. Now if I want to get back to that and work on it again, there's a work on command, and I'll just type work on IndyPy, and it activates that virtual environment and puts me now back into the space I was at before. I mostly don't, I don't use this for my projects because I'm usually using a virtual environment that's sitting inside that project, but I do use it for like little one-off tools, like especially things like glances or HTTPy or little command line tools that are built in Python. I want to install them in my system, but I don't want to install them as root. I don't want to install them into like user local or user bin. And so if I do work on tools, it switches me. You can actually switch between them. You don't even have to deactivate, which is also kind of nice. I can now use HTTP, which is the HTTPy command. So if I do HTTP indypy.org, that actually goes off and does a web request, and it shows me that it's going to redirect me to the HTTPS version of the tool. But that's only available in that specific environment. Now I've done a little trick. If I do this, I'm not in a virtual environment, but I was able to use the tool. That's because I've added that tools directory to my path. So that virtualenv tools bin HTTP, I've actually added that bin directory to my path so I can actually use those tools anywhere I want. So that's pretty handy for installing quick little tools I want to use on my local system. Or if I'm on remote systems, I do this a lot as well, because typically I don't have administrator access to those remote systems, but I do have kind of full reign over my home directory. So I can install whatever tools I want in my home directory. Luckily, Python gives me some awesome tools for doing work like that. All right, next fail. It works for me, but it doesn't work on my coworker's laptop. Oh my gosh, this is so frustrating. Like, I got it running on my machine, and they can't get it working on theirs. This has happened to me numerous times where I can get something running and someone else can't, and we need to be able to make these repeatable environments. And this is where we're going to talk about Pippins. This is kind of the latest and greatest in packaging, not packaging tools, but installation and dependency management tools. So Pippins basically will create repeatable sandboxes. So it's kind of the combination of pip, for installing packages, and virtualenvs smashed together, kind of like peanut butter and chocolate. They go great, two tastes that go great together. There is certainly no shortage of controversy in the Python community around packaging and how to install stuff, and that definitely applies to Pippins as well. It is a tool we're currently using. It's definitely not without some issues, but it's definitely one of the better ones we've ever dealt with keeping things up to date. If you've ever used like JavaScript or Node tools, like you get that package.json, which has like a lock file of like hashes for all the things that are installed, Pippins does that same type of thing for Python. It allows us to quickly create virtual environments, install tools into that virtual environment or install libraries into that virtual environment for our projects, and then move along with our work. And at the same time, it actually tracks those down to a pip file for us automatically, which is super nice. So to get Pippins installed, you can install it from Homebrew. So if you're on a Mac, if you're on Linux, you can do app install pippinv. Worst case scenario, you can do pip install -- user pippinv, and that will install it into your home directory, but it will use the system Python to execute it. I recommend, the kind of primary recommendation is actually to use the package managers for that. Since this is more of a global tool you'll be able to use, you can actually use it like virtual environment, like virtualenv, to say I want to use specific versions of Python for these sandboxes, and pippinv will also allow you to ensure certain versions of Python are used for your project. Something that setup.py and pip can't do is if you're requiring a specific version of Python for your project, you can't specify that in the setup.py file or even in your requirements.py file, but you can put it in your pip file. I did find out of a new tool. There is, if you guys are familiar with Homebrew, there's a Linux brew, if you're on Linux, which allows you to install stuff into your Linux machine without using root. So it's one of the beauties I liked. One of the things I liked about Homebrew was you just brew install as your own user, and it installs the stuff. And if you didn't like it, you could just basically remove that whole directory, and it uninstalls all of Homebrew. Though Linux has the same thing called Linux Brew. I've not tried it yet, but I'm definitely going to check it out now that I know that it exists. So in this case, we can do make dir my project, cd into the project, do pippinv install requests, and it will do a lot of the work for us. So I actually want to show that to you real quick. So we will do exactly that. We'll do make dir my project. Oh, we'll spell it wrong. Oh, that's weird. Oh, I know why. Let's try that again. Make dir my project. cd into my project. Now inside of my project, it's completely empty. There's no virtual environment, there's no nothing, because I just made the directory itself. But if I wanted to start a Python project here, and I wanted to have requests available as like the first library I'm going to use as part of my tooling, this will actually go and make a virtual environment with Python 3.7.3, and then it installs the requests into that virtual environment that it created for me. And you can pick what Python to use for it. In this case, I want the latest. And now I have two files in my home directory, or this directory for this project, called pip file and pip file lock. And if we look at the pip file, you can see that it basically says what packages I'm going to install. In this case, it says any version of requests is fine, but if I want to specify specific versions of requests, I can. And then it also has down here that I require Python 3.7. So if I was on a project that required 3.6, and I went to actually install requests into that environment with 3.7, it would get mad at me and say, listen, the guy who set up this project really wants you to use 3.6, and so you should use 3.6. So that's a quick overview of pipenv. It is quite nice. You can actually get into the virtual environment quickly. So like we were using the virtual env wrapper, we could type work on in some specific environment. If you're in that directory and type pipenv shell, you will get a virtual environment activated for you automatically. So if you type Python, you're using the one from the sandbox and not the system Python. All right, fail number 5. I have to go through this really quickly because we're starting to run out of time. If I have to work on a legacy project and I need to use Python 2.6 or 2.7 or Shutter 2.4, don't laugh. We have to do it. We have some Python 2.4 projects still in our environment. How do I do it? It's getting pretty tricky. Actually, this doesn't work for all Pythons because I tried installing a 2.4 earlier and I ended up in a seg fault situation. I think the compilers are too new for the old source code that Python was written for. But if you're using a fairly modern version like 2.6, even 2.5, this should work for you. So use pyenv. Quick and easy to install. You basically curl on pipe to bash. It doesn't install into the system. It installs into your home directory. So that's why you don't need to use sudo. So it's safe-ish. Definitely review those scripts before you run those kinds of tools. But I've looked at it. This one worked for me great. This allows me to build custom versions of Python where it downloads the source from python.org, builds the whole thing, installs it into a specific directory inside my home directory, and now I can go from directory to directory or project to project and say, use a specific version of Python while I'm in this directory. And anytime I go into that directory, I'm using that version of Python. Anytime I go out of the directory, I'm using the system Python or whatever Python I've set to be my global interpreter. If you just go and try and run that command without following the build problems page first, you will end up in failure because there are certain dependencies Python needs there to compile, and that page lists off basically some cut and paste snippets of app install these 10 packages, and your system will be ready to go. Same thing for like Homebrew. You need to have certain base dependencies for Python itself to compile, and then you'll be good to go. So in this case, if I want to actually use a older version of Python, I would use the pyenv install command. And if you do install -l, it'll show you all the versions of Python that are available, which are a lot. So if I show you, if I do pyenv, you can see you can install, oh my gosh, tons of different versions of Python. PyPy, stackless, condas, anacondas, plain old Pythons. It claims version 2.1, but you better have an old compiler on your system for that to actually work. And so once that compiles, you can go into your project and you can now specify pyenv local 362. And now when you type pyenv versions, it'll say, I'm going to use 362 when I'm in this directory. So if you type Python and do -m vm vm, it's going to make a virtual environment sandbox with that specific version of Python and not any other system ones. All right, last one. You're on Windows. That's, I guess, like a landmine alone. Luckily, if you're on Windows, many of these things I just showed you work, but you'll still run into some problems if you're getting into like scientific computing and data science type work. Because there are going to be C-compiled extensions to a lot of those tools that you need to use. There'll be GUI bits for like running Python notebooks, or if you want to use the, there's a couple IDEs that are kind of built into some of the data science people's tools. You're going to want to use Anaconda. I think that's a good recommendation for data science folks where you aren't necessarily a web series, like you aren't a web developer, or you aren't doing other kinds of development, you are doing data science day in, day out, and you need to do analytics work, and you happen to be on Windows. Even on other platforms, Anaconda is still a really decent platform if your primary task is doing data science related things. Because it's going to give you pre-compiled packages all built and ready to go for you. Now, that comes with a caveat. If you go to install Anaconda, it's going to download about 650 megabytes of stuff to your computer and then install onto your computer. So you better have some disk space free to get Anaconda going on there. So the installation is easy. You go to anaconda.com/distribution. You select Mac, Windows, or Linux. You download the installation exe, disk image, or like a shell file installer, and away you go. And what you end up with is a nice set of tools for being productive on your machine as like a data science tool. You'll have the Anaconda Navigator, which basically lets you launch a lot of the other tools very easily. The Anaconda Prompt, which will basically give you a shell prompt that's basically fully loaded and ready to go with every last tool you need to do data science. And then you have the Spider IDE, so full-blown IDE for doing coding and building your apps. And Jupyter Notebooks, if you guys are familiar with that. That can be tricky to get going on Windows if you don't have these pre-compiled packages or a C compiler on your Windows machine. And then the Conda CLI tools, so you can actually do Conda from the command line to install additional packages into your Anaconda installation for working on Python stuff. So that is a way to be successful and not fail and try and avoid all the landmines when getting started with Python.